Welcome back, everybody, to linuxacademy.com. My name is Terry, and in today's course, we continue our preparation for the Linux Foundation Certified System Administration exam. Specifically, we're going to be talking about static routing today. We're going to split static and dynamic routing and how we route traffic just to avoid any confusion. So from a static perspective, we look at routing traffic that is going from one IP address to another following the non-default route. And what do we mean by that? So if we look at our client, we've got two clients running, and we happen to be running CentOS 6 and CentOS 7. And if we do there's two ways to look at how our routes are set up. We can do the old netstat -rn, which will tell us everything for all IPs is going over the following gateway and interface, and the destination for 1.0 is ourselves. So basically we're saying that we're going out our own interface for all connections going to 1.1, which just happens to be our switch or router internally. So anytime that I go out and I do a ping, for example, to Google, if I were to do a trace route to google.com, then the first hop, as they say, is going to be to our default gateway. Now, technically, that's static routing, meaning that all of my traffic is going out a single gateway address. However, I can statically route between a couple of different networks by putting in a static route. And again, rather than doing a netstat -rn, which is the old deprecated way of looking at my routing, I can do a IP route show. We're going to show both ways of doing this using the old route command as well as the IP route command, just so that we understand the two things. So we have two examples that we're going to do. This particular server happens to be running Docker. So we've got some Docker images running on a particular IP address, and if we look at our ifconfig, we see that we're going to have 172.17.42.1, which is my Docker interface on this particular system. It could be another network interface. It doesn't matter that it's Docker. And then I actually have another Docker's container running, so that if I do a ping on 172.17.42.1 locally, or on 0.1, which is my container, I can ping locally those two IP addresses. Whereas if I go to my external client and I ping on 172.17.42.1, I won't get anything back because I don't know how to route there. There's nothing that can answer for that particular IP. I'm going out through my default gateway, which is going out through its default gateway to the internet and not getting a response for that particular set of IPs. So I don't get anything here. So I can statically route through my interface by adding a static route to my routing table. And I can do that, first of all, I want to make sure I understand what my configuration is, because in this case, CentOS, I'm getting the ENP0S3, which is telling me that my Ethernet on port 0 in slot number 3 on my system instead of the old ETH0, 1, 2, or 3 for older systems. So I need to just make sure I understand what my device is locally. And I also need the IP address from my client system over here. So my client IP here is 1.131, which is going to serve as the default gateway for the 172 networks that we just tried to ping. So there's two ways of doing it. There's the older route add method, and then there's the newer IP route add method. So let's start with the old one. And we're going to do a route add -net on 172.17.0.0, and then net mask 255.255.255.0, which basically is like saying the network 172.17.0.0/24, everything in that last octet, so up to 254 routable addresses. And then I have to tell it, well, what gateway am I going to go through? 192, 168, 1.131. And then I'm going to add my device, which is what we looked up above, ENP0S3. So again, using the older deprecated route command, it still works. It probably will for quite some time. I'm adding a route for the network 172.17.0.0 with this net mask, which effectively qualifies it as a /24 or a Class C address, using the gateway of 1.131 and the device ENP0S3. So I'm going out my network card and I'm going to this particular IP to reach anything on this network. And now if I do a netstat minus RN, I see that anything going to 172.17.0.0/24 is going to go out ENP0S3. So now I should be able to ping 172.17.0.1. And now I get a response back because that IP address is listening on my second device, which knows how to respond for that IP. Now the other IP, which was 172.17.42, we're going to add with the new route command. So we can do an IP route show using the new commands for changing routes. We see that the default is via 192.168.1.1 on device ENP0S3. It's a static route. And then we've got a static route here, 172.17.0.24 via this gateway. That was the rule that we just added. And anything on the 1.0 network goes out through this particular device for our IP. So what we want to do now is we want to do a IP route add. So it's a little bit of a simpler command. We're going to add a route for 172.17.42.1 simply because we're only needing to route for a single IP in this case. We don't need to put in a net mask. We don't need to put in a slash because we're actually only routing for the .1 command. But we could put, for example, if we wanted to route for everything on the 42 network, which we'll go ahead and do, we're going to say via 192.168.1.131. And again, our device is ENP0S3. And now if we do an IP route show, we see that we've got these two static routes. Again, this is our old one, pings 172.17.0.1, which we have a result from, and 42.1, which we now also have a result from. So there are a couple of ways of making it persistent. You can add it to the network scripts, or you can add it to rc.local, these exact commands. And if you want to remove them, and again, let's do an IP route show. If we want to remove those, we do an IP route delete. And we don't need to type everything in there. We just simply type in the network that we want to relieve, IP route delete 172.17.42.0, and then /24. And we do an IP route show. And we see that we're just back to the default or netstat minus RN. And then if we ping 172.17.0.1, which we were able to reach before, we no longer get a response, nor do we get a response from the 42.1 because we've removed that static routing. So that's how we set up static routing on our devices, and it doesn't matter how many gateways, it doesn't matter how many interfaces you have, you can control routing across networks. And in fact, this is generally from an internal standpoint on switches, how you kind of configure routes in multi-interface switches or switches with trunk ports, etc. This is the kind of activity that you do. You're defining gateways on different networks, on different ports and interfaces, so that you can statically route this traffic around. So for routing static traffic, that's all there is to it. My name is Terry for Linux Academy.